Hello everyone. Welcome to my virtual classroom. This is Lalita ma'am and you are watching my channel Mantram by Lalita Rao. So today we are going to discuss about scalars and vectors. If you want more such videos on this chapter motion, then the link is given in the comment section as well as in the description box. So do watch more videos to get more knowledge. So without further delay, let's start scalars and vectors. Okay. So in our daily life, we get to see many physical quantities. So some physical quantities to measure them. Suppose if I want to measure the mass of this notebook, then I'll say, let us say 100 grams, 200 grams, 300 grams, isn't it? So this 100 grams, 200 grams, this 100, 200 and 300 grams, it is sufficient. These words are sufficient to tell us about the mass of this notebook. Similarly, if I want to weigh this pencil, so if I say, let's say again 50 grams, so 50 grams or 10 grams is the mass of this pencil. So this 50 grams is nothing but it is sufficient to tell us about this mass. But there are some physical quantities for them. These things are in these this information or this piece of information is insufficient. So to differentiate between them, we have given them different names. So scalars are the physical quantities. In physics, when you talk about some physical quantities, so the physical quantities which obey algebraic law of addition, or we can say the physical quantities that have magnitude alone, they are known as scalars. So when I said 10 grams, so this 10 was the magnitude, the numeric value. Magnitude means the numeric value. Okay. And this grams, what is this grams called? So this grams is nothing but it is the unit of measuring mass. So this to measure the mass, it is sufficient if you know its numeric value and its unit. So such quantities are known as, such physical quantities are known as scalar quantities. So we can say that mass is a scalar quantity, right? Now also the physical quantities which obey algebraic law of addition. Now what do you mean by algebraic law of addition? Suppose I have 2 kg of apples, then my friend has again 3 kg of apples. So together, how many apples we have 5 kg of apples. So this is like is it clear? Like we can add them algebraically, these scalar quantities. And so these scalar quantities, they have only magnitude. They need only magnitude to represent them. They need only a value to represent them. Okay. And the magnitude is represented by a number as well as unit. So if you want to represent anything's magnitude, then you need a number as well as a unit. So as you can see here, this the mass of this ball is 500 grams. So here, this 500 grams is nothing but it is the 500 is the numeric value and grams is the unit. So this ball of mass 500 grams, when I say, it gives a complete sense. So such physical quantities are known as scalar quantities. So in this chapter, you are going to listen many such scalar quantities like distance, mass, speed, and so on. So we'll again explore further about the same. Okay. Now, after that, let's go further and see the next. Okay. Now, after that, let's discuss more about scalars. So as already discussed before, scalars, they obey algebraic law of addition. Okay. So as they obey normal algebraic operations, so we can simply add or subtract them. So 2 kg plus 5 kg gives us 7 kg. Similarly, 5 kg minus 2 kg gives us 3 kg. So I have 5 kg of apples and I have given 2 kg of apples to one of my friends. So how many apples I have? How much apples I have? I have 3 kg of apples left. then it cannot have any other value. It cannot have any other value. So for examples of scalars are mass, time. So mass already we have given example. Now if I say what's the time now? So if I say it's 9:30 p.m. So 9:30 is the numerical value and p.m. is the unit to represent it. Similarly, the distance, 2 kilometers, 5 kilometers. So 2 is the numeric value and this is the unit of measuring this value. Okay. Similarly, speed. What is the speed of the car? So let's say 100 meters per second. So 100 is the numeric value and meter per second is the unit. So the magnitude means simply the numeric value and it has a unit as well. Now after that, let's discuss about vectors. Now what are vectors? Unlike scalars, as scalars, to represent scalars or to tell us about scalars, we need only little information about its magnitude. But there are sometimes, suppose if you are to explain what are scalars, let me give you one example. Suppose you are in an army, okay, and you have received a call, move 2 kilometers. There is an attack from your enemies and then you are saying to move 2 kilometers. So if someone, your officer gives you instruction to move 2 kilometers and the phone disconnects, so move 2 kilometers where? Is it a complete information? No. Where? To move to the left, towards east, towards west, or towards north. So this was just a simple example. So it means it's an incomplete information. There it's necessary to mention the direction as well. Okay. So in physics as well, we have some physical quantities which depend upon or that depend upon the direction, where direction plays a very major role. So such physical quantities that need magnitude as well as direction, those physical quantities are known as vector quantities. So some of the examples of vector quantities. Suppose here, if I have said move 2 kilometers, it's incomplete information. But move 2 kilometers towards east. So here, this is direction and this is magnitude. So vectors, they need magnitude as well as direction. So the physical quantities that have magnitude as well as direction, they are called as vectors and they obey geometric law of addition. Geometrically, they obey the geometric law of addition. Then examples are displacement, velocity, torque, acceleration, and force. So as let's understand with displacements example. If you have moved, suppose let us say 2 kilometers from your home to your friend's house and towards the south, and then you have again moved 2 kilometers towards your school, towards in which direction? Towards the east direction. So here you have moved towards south and here you have moved towards east. So if I say what is the total distance traveled by you, then it will be, distance will be 2 kilometers plus 2 kilometers. This will be 4 kilometers. This is the total distance traveled and displacement will be, it will be the shortest distance between initial and final position. Your initial position was your home, your final position is school. So what is the shortest path to travel from your home to school? So obviously that shortest path will be a straight line path. So this straight line path is known as displacement. So if you change here the direction, so same example, if you start from your home to friend's home, 2 kilometers, and then from there again you move towards the school straight towards the same direction, then this 2 plus 2 distance will remain same. But in this case, displacement will also be 4 kilometers, initial and final position. So in this case and in this case, in both the cases, distance and displacement, distance is same, but displacement is different. So direction plays a major role here. So for displacement, we can say that it depends upon direction. Yes. So in the same manner, there are other physical quantities that depend upon the direction, and such physical quantities are known as vector quantities. Okay. Now, let's go further. Yes. And let's study the difference between scalars and vectors. So it's just a quick revision of the topic. Scalars are the physical quantities that need magnitude only, and vectors are the physical quantities that need magnitude as well as direction to represent them. Scalars, they obey algebraic law of addition, and vectors, they obey geometric law of addition. And scalars, examples of scalars, it is speed, distance, and examples of vectors, displacement, velocity, so on. So I hope this is clear to you. So in the next video, we'll discuss some questions based on distance and displacement. Okay, until then, bye-bye. And yes, don't forget to like, share, and subscribe to my channel.